All right, today we move into Chapter 7. Section 7.1, we're going to start looking at trig identities, and we'll have several sections involving trig identities. First off, what is an identity? Anybody tell me what an identity is? Do you know any identities? Here's an identity. Not a trig identity, but here's one that you know. What's A times the quantity B plus C? How else could you write that? AB plus AC. And what did you use to do that? The distributive property. All right, this is usually called the distributive property or the distributive law, but it's also an identity. So what's an identity? What do I mean to say it's an identity? What numbers can you plug in for A, B, and C? Anything. So what's an identity mean?
Like a formula that you can plug anything into?
It's a formula that's always true. That's all it means. It's a formula that you can plug in any numbers in the whole wide world and it'll work. Here's another one. Give me another way to write A plus B quantity squared. Excellent. I was hoping nobody would say A squared plus B squared. That's the mistake a lot of people make. It should be A squared plus 2AB plus B squared. All right, so those are some algebra identities that you've looked at and you know. Today we're going to look at trig identities, and we have a whole bunch of them already that we know. For example, we know that tangent x is sine x over cosine x. That's an identity that we know. Give me some more identities that are kind of along those lines. Give me more identities that involve fractions like that with sine and cosine and tangent and secant. And shout them out. Okay, that would be another way to rewrite the same identity. If I would have multiplied both sides by cosine x, that would be really the same identity, just written in a different way.
Secant over 1 over cosine, or
Secant
over,
is
1 over cosine.
1 over cosine, good. And that one could also be written as cosine is 1 over secant. Could be written either way. All right, so the other ones that we know, what's cosecant? 1 over sine, which again could be written as sine x is 1 over cosecant x. Okay. Any other identities you know like this? How about cotangent x? What can you tell me about cotangent x? It's equal to 1 over tangent, that's true. Or this could be written as tangent x is 1 over cotangent x. I'm going to write it back up here. The answer I was looking for was similar to this one, where tangent is sine over cosine, cotangent is cosine over sine. Okay, so there's a whole bunch of identities that we had. Here was another one. I'm going to draw a triangle here. And I'm going to call this angle theta right here. I'll call that A, B, and C. If this is the angle theta here, what's that angle up there? Well, what can you tell me about this angle theta and this angle up there?
Angle there is equal to theta plus 90 minus 20.
Close. You get your pluses and minuses backward. It should be this angle up here is 180 because there's 180 total in the triangle, minus 90 minus the theta. In other words, this is 90 degrees minus theta, or I'm going to write it as pi over 2 minus theta. Okay, so here's the identity I'm getting at. What's the sine of theta in terms of A, B, and C? A over C, opposite over hypotenuse. That happens to be exactly the same as cosine of pi over 2 minus theta. This angle up here is my angle pi over 2 minus theta. And how would I find the cosine of this angle? Cosine is adjacent over hypotenuse. And I could do the same thing with cosine. I could say cosine of theta is, what would the cosine of this angle theta be? B over C. That happens to be exactly the same as sine of pi over 2 minus theta. Because again, pi over 2 minus theta would be this angle up here. Its opposite would be B. Hypotenuse would still be C. Okay, so there's two more identities. Sine of theta is exactly the same as cosine of pi over 2 minus theta. And conversely, cosine of theta is sine of pi over 2 minus theta. All right, so by looking at the graphs of functions, we determined that y equals cosine x is even, which means cosine of negative x is cosine x. Even functions simply eliminate minus signs. They just get rid of them. And we also saw that y equals sine x is odd, which means sine of negative x is, what do odd functions do with minus signs? They put them out front. So sine of negative x is negative sine of x. Questions on those two? All right, the last identity we have in this section for now, for today, all right, it's called the Pythagorean identity. Pythagorean, that's a famous word. What do you know about Pythagorean? Well, it usually comes from the Pythagorean theorem. What do you know about the Pythagorean theorem? And when does a squared plus b squared equal c squared? What are a, b, and c? A and b are legs of a, what kind of triangle? A right triangle. And c is the hypotenuse. All right. So I'm going to draw myself a nice right triangle here. This will be my angle theta, A, B, and C. What's the sine of theta? A over C. And what's the cosine of theta? P over C. All right, so here's the Pythagorean identity. I'm going to take sine squared theta and add cosine squared theta. Well, sine squared theta, that's going to be a squared over c squared. And cosine squared theta will be b squared over c squared. That's a squared plus b squared over c squared. And then this is why this is called the Pythagorean identity. What's a squared plus b squared? C squared. That's the Pythagorean theorem. So this is c squared over c squared. C squared over c squared is 1. All right, so that's known as the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Now, sometimes we see this written in different forms. Sometimes you see this written as 1 minus cosine squared theta equals sine squared theta. How did I get that identity? I solve for sine squared. I subtracted cosine squared on both sides. And it's also sometimes written as 1 minus sine squared theta equals cosine squared theta. All right, now I'm going to take this Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And I'm going to divide everything by cosine squared theta. What's sine squared divided by cosine squared? Tangent squared, that's correct. Tangent squared theta plus, what's cosine squared theta divided by cosine squared theta? 1 equals, what's 1 over cosine squared theta? Secant squared theta. So there's another form of the Pythagorean identity. The Pythagorean identity can also be written as tangent squared plus 1 equals secant squared. And then again, sometimes we manipulate this around. Sometimes you'll see this written as tangent squared theta is secant squared theta minus 1. And sometimes you'll see it written as 1 equals secant squared theta minus tangent squared theta. Finally, I'm going to take this same identity, sine squared theta plus cosine squared theta equals 1. And this time I'm going to divide everything by sine squared theta. What's sine squared theta divided by sine squared theta? 1. What's cosine squared theta divided by sine squared theta? Cotangent squared theta. And 1 over sine squared? Cosecant squared. So there's yet another form of the Pythagorean identity. And again, sometimes this one is rearranged in different forms. You'll see cotangent squared theta is cosecant squared theta minus 1. Or you might see 1 equals cosecant squared theta minus cotangent squared theta. So there's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 different looking versions, and they're all called one identity. They're all called the Pythagorean identity. So there's really 9 different forms of it. Questions on that? right, number 1 says multiply and simplify. We have sine squared theta plus or sine theta plus cosine theta, whole thing squared. What would you do? You could use FOIL, okay? So you could write this as sine theta plus cosine theta times sine theta plus cosine theta. Your other option would have been to use that little identity that we had for a plus b squared and do it that way. All right, so let's see. What's sine theta times sine theta? Sine squared theta. Then we have sine theta times cosine theta. And then we have another one, sine theta, cosine theta. I did switch the order on that one. And then on the end I have cosine squared theta. So there's the multiply part. Now how do we simplify? Add the two together? Add the middle two together? What about the last two? They what? Why do they equal 1? That's the Pythagorean identity. It's a trig identity, you were right. More specifically, it's called the Pythagorean identity. Sine squared theta plus cosine squared theta is 1. So simplified, we would write our answer as 1 plus 2 sine theta cosine theta. Questions on that one? All right, I'm going to skip number 2 and jump to number 3. Number 3 says factor and simplify. How would I factor tangent squared minus cotangent squared? Well, let me give you an easier problem. How would you factor x squared minus 4? X plus 2 and x minus 2. Why is that one x plus 2 and x minus 2? Because when you do FOIL, the middle two terms cancel out. This is called difference of perfect squares. Notice what I have here. I really have two perfect squares, two things being squared, and it's subtracted. This is difference of perfect squares. So how do you factor tangent squared minus cotangent squared? It's going to be, I didn't leave enough room, tangent theta plus cotangent theta. And then the next one's going to be tangent theta minus cotangent theta. Well, I don't think there's a whole lot of simplifying I can do there. Tangent theta plus cotangent theta, those don't add up to anything that I know of. And tangent theta minus cotangent, those don't subtract to anything that I know of. So I think that's the best I can do with that one. So I'll leave it like that. All right, how about number 4? What can you do with number 4? You can certainly factor out a 3. So that's going to be 3 times cotangent squared theta plus 2 cotangent theta plus 1 cotangent squared theta on that first one. Can you factor more than that? I can't factor out a cotangent theta. Why not? Because there's no cotangent theta in this last one, is there? It's not a common term. Well, again, think of an easier problem. What if I had originally given you 3x squared plus 6x plus 3? You would tell me you can factor out the 3. And you'd have x squared plus 2x plus 1. Can you factor x squared plus 2x plus 1? The answer is yes. X plus 1 and x plus 1 again. So this would be 3 x plus 1, which you might write as 3 times x plus 1 squared. How is this different? How's it different to have cotangent squared theta plus 2 cotangent theta plus 1? It really isn't any different at all, except it looks more confusing. Instead of just having the nice little thing x written, we've got this confusing looking thing cotangent x, or cotangent theta. But how can you factor cotangent squared theta plus 2 cotangent theta plus 1? Cotangent theta plus 1 and cotangent theta plus 1 again. That's right. So that's going to be 3 cotangent theta plus 1, cotangent theta plus 1, which we might write as 3 cotangent theta plus 1 quantity squared. Questions on that one? All right, I'm going to skip number 5. Number 6. There it is, number 6. What would you do with number 6? And how would you simplify? That's true. Sine x over cosine x is the same as tangent, so then I would have tangent squared minus 1 over cosine squared. Oh, very good. All right, so what she's saying is sine over cosine is tangent, so this becomes tangent squared x, and then 1 over cosine squared would be secant squared. So that's the same as tangent squared minus secant squared. Looking back on my list here, I have it the other way. I have secant squared minus tangent squared equals 1. So if secant squared minus tangent squared equals 1, what can you tell me about tangent squared minus secant squared? I would multiply this equation both sides by negative 1. The answer is negative 1. That's not the way I would have done that problem. But your way is very good and it's 100% correct. Here's what I would have done. I would have said this is sine squared x over cosine squared x minus 1 over cosine squared x. And I would have noticed that right away I already had common denominators. That's something I always look for when I see fractions or common denominators, which tells me this is sine squared x minus 1 over cosine squared x. But what can you tell me about sine squared x minus 1? Well, it's the same sort of deal. We have 1 minus sine squared is cosine squared. So what can you tell me about reversing that? What can you tell me about sine squared minus 1? It's going to be negative cosine squared. Again, I'd have to multiply this equation both sides by negative 1. So I would have written this as minus cosine squared x over cosine squared x, which is negative 1. That's how I would have done it. What's the moral of the story? Your way is quicker. That's right. The teacher's way is not always the best way. But that would have, honestly, that's the way I would have done that problem. I would have noticed right away I had common denominators and I would have used my common denominators. Your way took less steps.
But you have to remember more which theorem you have to use. So you have to like make sure you memorized what tangent squaring is.
Well, I would hope at this point you better know that sine x over cosine x is tangent x. If you don't know that, you're in trouble. And you also better know that 1 over cosine is secant. So I would hope those are already memorized. They better be. If not, there's a problem. And then the only thing would have been recognizing the Pythagorean identity. All right, how about number 7? What would you do there? I would go ahead and FOIL. So I would have 1. And then I would have plus square root of cosine y. And then I would have minus square root of cosine y. And then I would have minus cosine y. Simplifying, I have 1 minus cosine y. That's the best I can do on that one. Questions on that one? All right, number 8 I'm going to skip. Number 9. Rationalize. What does the word rationalize mean? Get rid of square roots. So this one says rationalize the denominator, which means I want to write this as a fraction or I don't have a square root on bottom. So what would I do to get rid of that square root down on the bottom? I'm going to multiply top and bottom by something. Square root of tangent. Why square root of tangent? Okay. So on bottom, what's square root of tangent times square root of tangent? It's just tangent because it would be square root of tangent squared, so that would just be tangent. On top, I would have cosine x times tangent x. What's cosine x times tangent x? Sine of x. Why is it sine of x? Because tangent is sine over cosine. So sine over cosine times the cosines would reduce. We would have sine of x left on top. Questions on that one?